this class. So yeah, in our previous class we looked at the concept of acid, base, and salt, and we simply say that acids are substances that have the characteristics of: number one, they are sour, they have sour taste. Acid turn blue litmus to red, as we know. And we also look at the types of acid. There are two types of acid. We have the organic acid and we have the inorganic acid. We explained that in our previous class. Okay, and organic acid and inorganic acid. And we say organic acid are obtained from plant, the product from an animal product, which we have example are ethanoic acid from vinegar, we have lactic acid, we have citric acid, lactic acid from milk, citric acid from lime and lemon, amino acid from proteins, fatty acid from fat and oil, ascorbic acid from vitamin C. And we look at inorganic acid, which are obtained from the combination of chemical compounds. And we looked at example, we have hydrochloric acid, HCl, that is obtained from the combination of hydrogen and chlorine. We look at tetraoxosulfate 6 acid, which is obtained from a combination of hydrogen, sulfur, and oxygen. And we look at trioxonitrate 5 acid, which is obtained from the combination of hydrogen, nitrogen, and oxygen. So we went further to look at the action or the reaction or the behavior of acid in a water solution. And we said that if acid is dissolved in water, it produces hydrogen ion as the only positive ion together with the corresponding negative ion. So we're saying that when an acid dissolves in water, we say that it's not saying that when an acid dissolves in water, right, the acid produces hydrogen ion as the only cation. So we say cations are positively charged ions. Okay, so it produces hydrogen ion as the only positive charge, the only positive ion. That means hydrogen ion is the only cation that acid produces when they are dissolved in water, and the rest of other elements are anions. Anions are negatively charged ions. All right, and we said the process by which acid dissolves in water to produce hydrogen ion as the only positive ion is referred to as ionization. Okay, we looked at that as we carried on. All right, so let's dive into what we have today. We're actually continuing from a concept of acid in solution. Now I'm going to move towards the end of the page here of page 899. That I'm going to move to. All right, so we say that if a large amount of water, the reason why I'm going there because we had already explained the other part. Okay, so if a large amount of water is added to a small amount of acid, if a small amount of water is added to a small amount of acid, the resulting acid solution is called a dilute. So if a large amount of water is added into an acid, a little amount of acid, the result is what? A dilute. It will produce diluted what? Acid. So water has the ability to dilute what? Acid. Also, if little volume of water is added to large amount of acid, it will give us concentrated acid. I got what I'm saying. So the acid that if little water is added to it, and it give us concentrated acid. Okay, let's move on. Let's move on. Wait a minute. Okay, so let me just read again. We've gotten that as well. Concentrated acid. So we're looking at the basicity of an acid. That's the main topic for today. The basicity of what? An acid. All right. Now let's go. Now, all acid in an aqueous solution. Aqueous means water solution. Okay, yield hydrogen ion, which can be replaced by metallic ions. So they say all acid in a water solution yield what? Hydrogen ion, which this ion can be replaced by metallic what? Ions. Right. Now, the basicity of an acid is referred to as the number. Please listen again. The basicity of an acid is referred is referred to as the number of hydrogen ion present in one molecule of an acid. I will take it again. The basicity of an acid is referred to as the number of hydrogen ion present in one molecule of an acid. Now, it is also the number of replaceable hydrogen ion, H positive, in one molecule of the acid. It is also the number of replaceable hydrogen ion, okay, in one molecule of the acid. Now, let's look at the basicity of some common acid. So we have types of basicity. We have monobasic, we have dibasic, and we have tribasic. Monobasic here, monobasic acid. Now I will read it very well. It's not in the notes, so please pay attention. Monobasic acid. Sorry, let me move to there we are. Monobasic acid. Now, monobasic acid. Please take this part. Take the note. It's not in the note there, so please listen carefully and take the note. So monobasic acid, these contain only one number of replaceable hydrogen ion. Monobasic acid contains only one number of replaceable hydrogen ion. The second one, an example of monobasic acid are hydrochloric acid. Only hydrogen is positive, while chlorine is negative. So is 1. Then the next one we have dibasic. Dibasic, this contains two number of replaceable hydrogen ion. Contain 2. Example are tetraoxosulfate 6 acid, H2SO4 is an example of diabasic. And finally, number 3, tribasic. This contains 3 number of replaceable hydrogen ion. Example is tetraoxophosphate 5 acid, H3PO4. So look at the summary. The table there shows the summary of this acid. So we have HCl. You can see hydrogen is positive and chlorine is negative. So that's 1. It has just one basicity, or is monobasic 1. Then we have H2SO4. You can see that hydrogen has 2 hydrogen ion. Yes, positive hydrogen ion 2. Then sulfur and oxygen are negative, so it's dibasic. And finally H3PO4, that is tetraoxophosphate 5 acid, has 3 hydrogen ion. Then phosphorus and oxygen are negative, so they are tribasic acid. All right, let's move on. Now I want us to note something. Note very well. Now, not all the hydrogen atoms in a molecule of an acid are replaceable. Not all of them are replaceable by a metal. Not all of them. Example, like the ethanoic acid. Ethanoic acid, for instance, has 4 hydrogen atoms per molecule of an acid, but only one of these is replaceable by a metal. So it is not about how many hydrogen ion or how many hydrogen atoms a molecule has, but how many can be replaced by a metal. That's what makes it a basicity. Okay, that will bring about basicity. The number that can be replaced, not necessarily the number it has. Okay. All right, we dive in again. We keep diving in. Just follow. All right, so yeah. So ethanoic acid is monobasic. Okay, even though it has 4 hydrogen ion, it has 4, but only one can be replaced by metal. So it has is monobasic. All right. Now look at the physical properties of an acid. Physical properties of acid. Number 1, dilute acid have a sour taste. Yeah, diluted acid has a sour taste. The sour taste of unripe fruit, vinegar, and rancid milk is due to the presence of acid in them. So you can see that most of these things, vinegar, unripe fruit is sour because of the presence of acid. Excuse me. Number 2, acid turn blue litmus red. That's one of the physical characteristics. Acid turn blue litmus red. Number 3, The concentrated form of strong acid like hydrochloric acid, triosonitrate 5 acid, and tetraoxosulfate 6 acid are corrosive. Corrosive means they can burnt. So for example, if you look at a car battery, if you take out the acid of a car battery and touch on your body, you will get burnt. I'm saying that because I have that experience. I have used it when I had certain injuries on my face. So I use those acid. I had some growth on my face. I used the acid from a car battery, and it is so hot, like very so hot. So yeah, what I'm saying is true. Yeah, I've experienced it. Okay, so what I'm saying in essence is that they say concentrated acid are what corrosive. They can burn the skin. They can cause injury. Okay. Next is now caution. There's a caution given to us here. The caution is this. It says never add water directly to a concentrated tetraoxosulfate 6 acid. It means never add water directly into a concentrated acid. Never try it. Never try that. However, because why? Because the hot acid solution can splash, and you get burnt. The best thing is always add water into an acid. Don't add acid inside water. Add water. Sorry, don't add water inside acid, but only add acid inside water. I got that I'm saying. Take acid, add acid inside into water, not adding water into acid. That's what I'm saying here. Then the chemical properties of an acid. Number one, there's reaction with metals. So acid has the capacity to react with metals. Then now let me read again. Now listen. Acid reacts with some metal like zinc, iron, and magnesium to liberate hydrogen gas. Such reactions are due to the displacement of the hydrogen ions in the acid by the metal. Diluted triosonitrate 5 acid, however, is an example is exception on this. I mean, these ones cannot react with metal, cannot be replaced with metals. So you can see acid, you can see metal will give us salt plus what? Hydrogen. So this is hydrogen has the capacity, acid has the capacity to react with metals, metallic element, right? Number two, acid reaction with bases. Acid react with soluble bases. Soluble bases are bases that can be dissolved in water. Sorry. Acid react with insoluble bases. Insoluble bases are bases that cannot dissolve in water. Okay, insoluble. So they are saying here that acid react with insoluble bases and alkalis to form salt and water as the only product. Such reaction is known as neutralization. So the process by which acid react with bases or with alkali and insoluble bases to produce water and salt is known as neutralization. Neutralization. So there's also reaction with trioxocarbonate 5. This is salt actually. Trioxocarbonate 5 is a salt. So they say that acid react with trioxocarbonate 5 to liberate carbon 4 oxide. Now, the three chemical properties listed above are characteristics of an acid. So acid here, they're looking at their interactions or the chemical characteristics. What makes an acid not just a physical compound, but a chemical compound is because of its ability to react and react with other chemical substances. Now, we're looking at how our acid preparation of an acid. So another of the general method for preparing, an outline. So this is an outline of how acids are prepared. Number one, dissolving an acid anhydride in water. And an acid anhydrides are non-metallic oxide. Please take it down. Acid anhydrides are non-metallic oxide that dissolve in water to produce various acids. non-metallic oxide that dissolved in water to produce various acids. Example, we have carbon 4 oxide is an anhydride of tetraoxocarbonate 4 acid. Tetraoxocarbonate 4 acid. It means that it means that carbon 4 oxide can dissolve in water. When it dissolves in water, to form weak trioxocarbonate 4 acid. Okay, we are making progress. We're making progress here. So just follow carefully. The next one. So let me just read out the process here. We said carbon 4 oxide dissolve in water to form a weak acid. A weak acid that tetraoxocarbonate 4 trioxo, not tetra, trioxocarbonate 4 acid. Next one is sulfur 4 oxide dissolved to form trioxosulfate 4 acid in water. Are you there? Sulfur 4 oxide dissolved to form trioxosulfate 4 acid in water. Next, now listen. The next one is sulfur 6 oxide dissolved to form tetraoxosulfate 6 acid in water. So you can see the process, the way in which acids are formed from already existing chemical compounds. I'll take it now. These non-metallic oxides which dissolve in water to produce various acids are known as acid and hydride. I think I explained this. A metallic substance that which dissolves in water to produce various acids. All right. Let's carry on. The combination of constituent elements. Combination of constituent element of an acid. Number one, we have burning hydrogen in chlorine. This is the second method of preparing acid. The first one is dissolving an acid and hydride in water. The next one is combining constituent element that makes up the acid. Number one, they say burning hydrogen in chlorine in the presence of activated charcoal as the catalyst yield hydrogen chloride gas which dissolve readily in water to give hydrochloric acid. So that's trying to say here that when hydrogen is burned in chlorine, burning hydrogen in chlorine, it will in the presence of activated charcoal as a catalyst, it will yield hydrogen chloride gas. And when this hydrogen chloride gas dissolves in water, it will automatically produce hydrochloric acid. Next. Excuse me. The second one under combination of constituent elements is heating hydrogen gas and bromine vapor in the presence of platinum as the catalyst. This produces hydrogen chromide gas which dissolves readily in water to form hydrobromic acid. All right, we are making progress. Yeah, this is where we are. Now the second one is the final one is using a strong acid to displace a weak acid or a volatile acid from its salt. So you can displace a strong acid from a weak acid. You can do that, or you can displace a volatile acid from its salt. Okay, let's move on. Please do listen to that voice that you're seeing there. I made a mistake. I didn't send it as a normal voice note. All right, let's carry on. Using strong acid, I've explained that now. A strong acid may be used to displace more volatile acid or a weaker acid from its salt. Yes, that's possible. So how is this done? Concentrated tetraoxosulfuric acid displaces the more volatile triosonitrate 5 acid from a triosonitrate 5 salt. Yes. The salt, e.g., sodium trioxocarbonate 5, must be in excess. Number 2, a chlorine yields the volatile hydrogen chloride gas when heated with concentrated tetraoxosulfuric acid. The volatile hydrogen chloride dissolves readily in water to give hydrochloric acid. Okay. There's some few minutes to go. Let's carry on. Now they say dilute hydrochloric acid, which is a strong acid, displaces the weak trioxocarbonate 6 acid from trioxocarbonate 6. The trioxocarbonate 6 breaks down to evolve carbon 4 oxide. What about that? Carbon 4 oxide. Return to the next page. Which carbon 4 oxide, the acid hydride, the weak acid is transformed by dissolving the carbon 4 oxide in water. All right. Let's carry on. Now, uses of acid. You can look at the table here that summarizes the various uses of acid. This table. Number 1, we said acid, hydrochloric acid. That was the use of hydrochloric acid. Number 1, needed by industry to make chemical. Number 2, used to remove rust, hydrochloric acid. Number 2, tetraoxosulfuric acid, uses needed by industry to make chemical. Number 2, used as a drying and dehydrating agent. Number 3, used as an electrolyte in lead acid accumulators. And finally, required to oil refineries. These are uses of hydrochloric acid. Uses of tetraoxosulfuric acid. The next one is trioxonitrate 5 acid, and this is needed by industry for making fertilizers, explosive, etc. Then we have boric acid, used as a mild antiseptic or germicide. That is boric acid. The next one is tartaric acid, used in making baking soda, soft drinks, and health salt. Next one, and health salt. Then we have the next one, acetic acid or ethanoic acid, used in preserving food. Yes. Used in dyeing silk and other textiles. Finally, the next number, last but not least, is citric acid, used in making fruit juice. And finally, fatty acid, used in the manufacturing of soap. The process is known as sponification. Sponification is the process by which a man produces soap and begins to sell by himself. Okay. So these are the summary of the use of acid. I also have this, a formula for use of acid. Okay, so this is where we draw the curtains for today. You have said so much. Go and digest this one. Go and keep studying more. Bye for now. Thank you.